Doctor of Science in Chemistry from University in Bergen and I finished there in 1996. In this presentation, I will give an overview of BIR's work with carbon capture that we started around 2015, 2016, and the carbon capture project, and also to discuss how waste handling and the emission from waste energy can be used to contribute to negative emissions globally. Just a few words on BIR. We have a history back to 1881 as the first waste handling company in the Nordic, and we are now one of Norway's largest waste handling companies. We both collect waste, we sort waste, we handle waste, and also put waste into recycling circles. And what we cannot recycle and reuse, that is what we call the residual waste that we treat in the waste-to-energy plant in Bergen. And that plant is also one of Norway's largest, and it's quite a medium-sized in European measure. So it's very interesting for the carbon capture companies to work together with us. I would like to say something about emissions from waste energy and also in global emissions. In Norway, we are emitting 41 million tons of CO2 equivalents as a greenhouse gases. And the waste corresponds to around 4% of that. BIR, as I said, we are responsible for handling the waste, and we are handling it in the waste-to-energy plant, the residual waste in Rådal. And one issue about the waste-to-energy plant is that that's a single point of emission, so it's much easier to reduce the greenhouse gases from one single point and to have these scarce emissions, like for instance private cars, to reduce these emissions from them. And if we can reduce or capture the carbon CO2 from the waste-to-energy plant, we can reduce amount similar to all the private cars in Bergen. And Bergen, they have a target to be a low-emission city, if I have translated it correctly, by 2030. That means that they aim to reduce the emissions by 85% in the greenhouse gas of the greenhouse gas emissions. And it's not possible for them to reach that target without reducing the emission from the waste-to-energy plant. I also would like to say that we all produce residual waste, but BIR is the company that's responsible for handling it. But we are all, as whatever we buy and whatever we put in the waste bin, that's our own responsibility. If we look globally on waste, this is a survey from the World Bank Group called Water Waste, and they are saying that 19% of all the waste in the world is recycled. That means that we are putting metal back to metal, using metal again. We are composting food, and we reuse building materials and so on. 11% is incinerated. That also includes waste to energy. 12% is landfilled, and with that we mean landfill that are strictly regulated, and we call them sanitized landfills, where they are controlling the water from the landfill, controlling what we are putting into them and so on. And actually in the world, 58% of the waste is put into landfill. It's dumped, it is uncontrolled, and then by that also goes into the oceans and so on. So just to put this into perspective, and in Europe, we are saying that we are the best continent in the world with waste handling. If we look into this survey from CEVEP, that's a Confederation of European Waste-to-Energy Plants, we say that in Europe, if you look on the column to the left, 50% of all the waste in Europe is recycled. Around 1/4 is recovered from waste-to-energy plants, and 1/4 is put into landfills. So also in Europe, if we look on the waste-to-energy plant, that in total, that is around 100 million tons are treated and energy recovered in waste-to-energy plants. And in Europe, we have around 500 waste-to-energy plants. And on the map, you can see also how this is for each country. So Norway has 8 plants, and we are treating 1.6 million tons. I will also, before we start with this, how we can contribute with negative emissions, it's important to see that the residual waste, again, what's after what we cannot use for other things like mixed materials and so on, that's also a mixture of biogenic CO2 and fossil CO2. So we get biogenic CO2 from plants, from food, and from and so on, and we get fossil from a lot of packaging material, a lot of plastic, and so on. The residual waste, or the waste, is sorted at your house, and the residual waste that you put in the dustbin is collected by BIR, and when we are incinerating it, we are recovering both heat and we are producing electricity. If we can capture the CO2 emissions, we see that if we are capturing 40% of it, then we have captured all the fossil CO2. So if we can capture more than the biogenic CO2, we can actually be carbon or be negative in the or climate positive, or what kind of word we should use about this. CVAP also, if we look into how the emissions is coming from waste, we say that 1 ton of waste produces 1 ton of CO2. And as I said earlier, 1 ton of CO2 is 400 kilos of fossil CO2, 600 kilos of biogenic CO2. Also, if we should replace the energy that we are producing in the waste-to-energy plant with other sources of energy, electricity and heat, that would need 360 kilos of fossil CO2. And also, if we should replace all the metals that we are recovering from our bottom ash, this calculation shows that we would need 60 kilos of fossil CO2 for this replacement. And that's not including that we should reuse the metals. If we are able to capture 500 kilos as a 50% capture rate, we say that we would need to use some energy for that capture, but still the net climate result would be minus 440 kilos for each ton that we are incinerating. And as you said, without the capture, we have a minus 20 kilos, or almost climate neutral. CVAP has also made a roadmap on carbon capture on all the plants in Europe, and saying that a status quo that says that we are almost climate neutral. If we can capture 50% of the waste of the CO2 emission from half of the plants, we will emit minus 20 million tons of CO2. If we can capture 50% on 90% capture rate on 50% of the plants, it will actually contribute with minus 40 million tons of CO2. And this is the basis for, and the importance that says that why Bergen has such a high focus, and why BIR should also work on carbon capture. We started a feasibility study in the fourth quarter of 21 and finished it first quarter 22. And that was together with Aker Carbon Capture and also Norsk Energi. And these are companies that we have had a close cooperation with for a long time. We said that we wanted to have a study based on capturing the emissions in a capture plant, also how much it will cost in energy for liquefaction and transportation, and also delivery to Northern Lights. This study, together with Aker, concluded that it's technically possible to establish a CO2 facility. It will be, of course, need a lot of energy, but one modular plant, that was the target for this project, is possible. And also we said that we need some stretch to be able to capture 90% of the CO2. So we need to also see how much place do we need for this. One issue with this, I said earlier from the CVEP that the waste energy is contributing with climate positive with producing energy. So if we are using all the energy that we are producing to capture the CO2, then we think that that's not contributing positive globally. In Bergen, we are currently producing 60 megawatt. That's our maximum to the district heating, and yearly 300 gigawatt hours are supplied for the district heating network. Electricity, we can maximum produce 15 megawatt electricity, and yearly we are producing 100 gigawatt hours electricity. We're not able to do that at the same time, but this is the maximum numbers. So how should we integrate this in a way that we are not using all our energy for the capture? And we have worked very close with Norsk Energi about this, and this is we have made many scenarios how we can use heat exchangers to make sure that all the electricity that we are putting into the carbon capture plant can be recovered as heat into the district heating. Of course, that means that we can increase actually the delivery on heat to district heating to over 70 megawatt. But of course, in the summertime, it's not possible for us to recover all the energy that we are putting into this capture. Based on the feasibility study, we had a pre-study in second and third quarter this year, and we delivered it in September this year. That was a project done together with the COVI and Scitech, and these are also the same consultancy that's worked close with the Oslo plant that is now introducing or now started to build the carbon capture plant. But this is also based on one modular plant. We based it on the Aker Carbon Capture's plant, but we are saying that this should be also, of course, possible for other suppliers of capture to deliver to us. We worked very hard to find the best location of the capture plant, including also the compression and liquefaction of the CO2, and also transporting and how the filling stations for transport to Øygarden. And again, we looked into this heat integration between the capture plant from the waste to energy plant to district heating. This is a schematic just to show. You see here, if you see my pointer, this is the waste to energy plant. This is the bunker, this is the incineration, and this is the flue gas treatment, the chimney, and this is the district heating central. So we need to place the capture plant. This is for one just catch plant from Aker. And you see it's quite space consuming, these, if we should capture 90% of or 95% of the emissions using this just catch. And we are saying that this is the space we need, but it doesn't necessarily have to stay exactly here. But just to give some indications on the size of the capture plant. We also looked into the investments in this project. And of course, this is quite immature technology, or at least they don't have so many experienced on delivery to waste energy plants. But we say that high uncertainty on factors like shifting prices, and also how much we should do on the heat integration, but we are estimating this as 1,000 million NOK or 1 billion NOK for a capture plant of 100,000 tons. We also looked into our operating costs, and we have some indications on that, and also how much we are using the electricity to run the capture plant. We see some upsides, both by reduced carbon tax, and also we think that it will be interesting for many suppliers to us, many customers to us, to reduce their greenhouse gas emissions, and also to pay for this capturing of the CO2. In the placement of the new capture plant, we are working very close with our with the regulatory Bergen, the county of Bergen, on how we should place such a capture plant and where to place it, what consequences that would have, and so on. So we have put in some recommended location, and also are, as I said, discussing this with the county of Bergen, and it also means that we need to go into a dialogue with our neighbors on how we should do this. We think that if we should achieve something as big as this, and in a good way, we need really to work very close with the other waste to energy plants in Norway. So the energy plants in all the large cities, Oslo, Stavanger, Kristiansand, Trondheim, and also an industry network in Borg, that's with Fredrikstad, Sarpsborg, is working very close into in a network called CAN, and that's a Norwegian for climate cure for waste to energy business, waste to energy sector in Norway. We share information, we work both all we learn, we share. We are now making a benchmark waste energy plant so that we can use to request information from the carbon capture suppliers and so on. And we also need to work into business models, how to make sure that we can finance such a large investment. And we need to speak with one voice towards the government in these issues. Very shortly on BIR and the carbon capture, as I said earlier, we started to orient ourselves in the carbon capture business in 2015-16. We had the startup of the first feasibility study in 2018, delivered in 2019. And that was also a survey of the available technology from Norsk Energi. We also started a very interesting project with Bergen Carbon Solution that some of you may have heard of. That's how they are using CO2 to produce carbon nanofiber, a specialty chemical that has some very interesting properties. In 2020, we started a pilot with Captico 2. That was how to mineralize CO2 to calcium carbonate. That's quite a different technology than compared to the amine technology that's normally used. We were invited into the advisory board as an industry partner in the newest CCUS European network. That's a negative emission for waste to energy sector. We started together with the other waste energy plants, the network CAN. And as I said, these feasibility studies that we did 2021, 22, and also a new, very interesting carbon capture project with SINTEF and Captico 2 that we started in 2022. That's called Continuous Swing Adsorption Reactor. And that's also a very interesting project that they will come to us next year to do a plant study capturing our flue gas and see if we can use that technology and try to lift that to TRL level 5. Yeah. A short status on where we are today. We have owners, as I said, if they should reach their targets, Bergen City, to be a low emission city, they need to have a capture at our plant, and that's also making us very interesting to have a close cooperation with Bergen Kommune, Bergen municipality. We are also thinking that we are interesting for Northern Lights because we are only 50 kilometers from Northern Lights, and we can develop this transport with trucks from us to Northern Lights. That makes them more interesting for other locals. We will continue this pilot testing that we have started, and also continue to do this testing on, the studies on how the technology is developing and how the costs are developing for the carbon capture. We think that the way forward for us is, of course, to continue to try to secure support for the project that we have in the capture plant. We need to have both dialogue with the local authorities, but also national authorities. And that's a lot of help that we have from this CAN network that we have together. We need to continue discussions with the Northern Lights to secure that they will also receive liquid CO2 by trucks, and to try to work to have some attention to these projects. I also mentioned that we need to have somewhere to place the plant, so we need to acquire the needed space for it. We will need to continue to choose the best carbon capture technology for BIR, our company, and also for Bergen. And the most, at least what I feel is the most interesting part, is also to continue to help local startups that are working in carbon capture projects, and to work close with them, and also close with the university and research environments to try to find best possible way to do the carbon capture in BIR. So that was just a picture from TCM. I guess that a lot of you have already been to TCM, and that's a normal way where we meet. This is also a picture from a cooperation that we have together with Copenhagen and Malmö and Kristiansand and Bergen. So we had also a meeting on carbon capture in TCM in Mongstad. So thank you very much for listening.
Thank you very much for your presentation. Very interesting, and we will now stop recording. I think my colleague Gry will do so. And then we open the floor for questions and comments from the audience. So please, just raise your hand and you will be allowed to ask your question.